What's up, math scholars? We're doing 10.3 today, verifying trig identities. I did pass out a little slip of paper to everybody in the classroom that has all the identities on it. So if you're absent and you're watching this video, just ask me for one of those when you get back so you don't have to write them all down because there's a lot. Hey guys, who's excited? It's Friday. I am. All right, so we're going to first things first look at the unit circle and just refresh what, all right, so we're going to take this unit circle. We are going to label it with radians just to refresh our mind on who would live in what quadrant and stuff like that. So as far as radians is concerned, who lives right here? 0 and 2 pi. Who lives up here? Pi over 2 and 90 degrees, right? Who lives over here? Pi and 180. And who lives down here? 3 pi over 2 and 270. So if you forgot those numbers, jot them down real fast. The first two problems we do today, you'll need to know on the unit circle where different radians live. So this is important. All right. You don't need to write down anything from the slide. I'm just going to kind of explain how we're going to be using the Pythagorean theorem with a unit circle. So everybody look at my unit circle. Basically, this would be a coordinate on the unit circle. The cosine stands for x values. The sine stands for y values. I could draw in a right triangle. My x values would be here. My y values would be here. And that's how I could use the Pythagorean theorem, because I have a right triangle. X squared plus y squared equals 1 squared. And since x is equivalent to cosine, they substitute that in. Since y is equivalent to sine, they substitute that in. And this is the most famous trig identity, called the Pythagorean identity. You don't even need to write it down, because it's on your little slip of paper. Can everybody find it on your little slip of paper?
Yep.
And circle it. So that's the one you use more often than any other one. It's under Pythagorean identity. It's the first one on the farthest left. If you're watching the video at home, everybody in the class has this slip of paper they have taped into their notebook. But this right here is the most famous Pythagorean identity that we'll be using the most often. Here is our first example problem. Basically what's going to be happening is they're going to give us one trig value. So they're going to give us that sine is 4/5. They're going to ask us to find cosine and tangent and secant and cosecant and cotangent. Remember when you have that list of all 6 of them? That's where we're headed with things. Now, before I get too far, I am going to explain what this means. This is their way of telling us what quadrant our answer will live in. So let's think about what quadrant our answer would live in. If pi over 2 is here and pi is here, and we want to be between those two values, what quadrant will our answer live in? Quadrant 2. Very good. So it's kind of good to think about quadrant 2 and what we know about quadrant 2. Would the sine values be positive or negative in quadrant 2? The y values. But what about the cosine values? And then what about the tangent values? Negative. Very good, because tangent's y divided by x. And then what about the cotangent? Also negative, because it's just a reciprocal tangent. Okay, so let's go ahead and start off with the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. We're going to use a bit of substitution. They did give us this provided information that sine theta is 4/5. So we're going to put the 4/5 in for sine. So it will end up getting squared, in other words. We'll do a little bit of calculations. 4 squared over 5 squared would be 16 over 25. Now our job here, our goal here is to solve for cosine. So what do you guys think would be my next step? Add, subtract, multiply, divide, square root. Subtract, good. We are going to subtract this 16/25 over to this side. And I'll use the calculator to help me do that. I'll type in on the calculator 1 minus 16 divided by 25, and then I'll hit the fraction button at the very end. So that gives me 9 over 25. Excuse me. All right, so now at this point, we are going to be solving for cosines. We are going to square root to make that happen for us. So cosine theta, whenever you square root something, it's positive or negative. We'll chat about that in a second, though. But it's positive or negative 3/5. Now, just a few short minutes ago, you guys told me that if we were living in quadrant 2, that our cosine would need to be negative. You remember that? Because your x values up in quadrant 2 are negative. So really what that means is we can't actually have two answers. It can't be positive or negative 3/5. It just has to be negative 3/5. So cosine x, cosine theta equals negative 3/5. So there's cosine. There's 2 of our 6. There's 6 total. All right, so sine, the reciprocal of sine, if you don't remember, I think it is on paper. The reciprocal of sine is cosecant. CSC is the abbreviation. And you'll just reciprocal your 4/5, so it'll be 5/4.
Why could it be a positive?
Because we're living in quadrant 2, and everybody who lives in quadrant 2 has a negative x value and a positive y value. Okay? Then the reciprocal of cosine is secant. Again, it's on the top of the paper if you've forgotten this. So the reciprocal of negative 3/5 is negative 5/3. Let's go ahead and talk tangent then. If you've forgotten about tangent, it's also on the paper underneath tangent and cotangent identities. Tangent of theta equals sine theta over cosine theta. So it looks like I'm going to have to take my 4/5 and divide it by negative 3/5. So you can definitely do that. Multiply by the reciprocal trick. I think it's kind of time for you to learn this trick though. If you have a 5 here and you have a 5 here, they're just allowed to cancel out. So that's what will happen when you multiply by the reciprocal. So it's negative 4/3. So tangent of theta is negative 4/3, which makes cotangent the reciprocal of that, negative 3/4. Okay. I like can't even recover from that. We're going to go ahead and start this off doing a unit circle, figuring out what quadrant our solution's in. So 0 lives here, and pi over 2 lives here, and pi lives here, etc. What quadrant do they want our solution in? Quadrant 1, yes. If you're in quadrant 1, you're in a really happy place because everyone's so positive. The x's are positive, the y's are positive. That means sine, cosine, and tangent will all be positive. Okay? So let's start ourselves up with our Pythagorean identity. Sine squared plus cosine squared equals 1. We're going to use some substitution. And we're going to substitute in a 1/6 in for cosine.
Why is it 0?
Why is 0 and 2 pi are the same exact thing, Spencer? They're the same exact location.
Okay.
Alright, so let's go ahead and square our 1/6 and get 1 over 36. And we're on our journey. We're trying to solve for sine. What should we do next? Subtract is correct, and you can use your calculator to do that, but just fraction the answer you get at the end, okay? Some of you might even be able to do that in your head. 35/36. Very good. And finish it off with a big old square root. Now we're kind of lucky because the 36 is a perfect square. 35 is not a perfect square, so I'm just going to leave it as radical 35 over 6. And it is positive because it lives in quadrant 1, so we don't have to worry about it being negative. But that completes our sine. So we're completed with cosine, and we're completed with sine. We just need to do the other ones, the reciprocal ones, and the tangent one. Alright, so at this point it gets kind of easy. We can do our reciprocal. So secant is the reciprocal of cosine. You can see that on your paper if you look. So that's just going to be 6 over 1, or 6. Cosecant is reciprocal of sine, so 6 over radical 35. I don't worry about rationalizing that denominator, but scholars can. Yeah, we're going to do tangent. Don't you worry.
Wow.
All right, we're back. We got our cosecant. And I heard somebody say, what about tangent? Don't forget about tangent. Don't worry, I didn't forget. It's going to be sine over cosine. Again, you can do your multiply by the reciprocal trick, or you can just recognize these 6's will cancel each other out. So it's radical 35. And then the last one that I got to do is cotangent, which is the reciprocal of tangent. Okay?
It doesn't matter.
All right, we've arrived at our next question. Everybody is so happy today. It's Friday. We're all asking really mature questions and staying on topic. All right. Our whole job here is simplifying. Sometimes you will simplify these and everything will cancel out and you'll be left with 1. Sometimes you'll simplify these and cancel things out and you'll be left with, I don't know, cosine. You just never know, all right? But it's your job to take your little sheet, your trig identity sheet, and just look for things that you can substitute out that may help you cancel something in the future. So for example, my eyeballs were really drawn to this guy. It was just so big and weird, and I was like, I wonder if I could find a trig identity that looks exactly like what's in my green box. And if I can, maybe I can substitute out that green box for something equivalent. Ethan? Nope. I'm looking under co-function identities. That's a hint. Co-function identities. It's the last one on that line. So I'm going to replace my green box with cotangent of theta. Okay. So I'm getting there. I've done one replacement. I haven't really found anything I can cancel yet. So somebody says, I'm confused. We basically took what's in the green box and we found it under co-function identities. And tangent of pi over 2 minus theta was equivalent to cotangent, so we just replaced it. We did a substitution. We're going to do another substitution. We're going to substitute out cotangent next. If you look under tangent and cotangent identities, that's the second, section, you can see that cotangent is equivalent to cosine over sine. Do you see where I'm pointing to? So I took my blue box and I replaced it with what I just wrote in blue. And you know why I did that, hopefully, because now I have something I can cancel. So I'm truly simplifying at this point once I'm canceling. And I'm left with nothing more than a single cosine, and you're done. So that's your job. Your job is to substitute, cancel, substitute, cancel, until you just can't substitute and cancel anything more. Okay? That's what simplifying is. We'll try more. They're weird. Some are easier than others. Some are hard. Some take little tricks. All right. This one is a little bit bigger, but we'll just go piece by piece, substituting and replacing and canceling until we can't do any more. This is probably a little bit longer than something I would make you do on a quiz, but we'll get through it. So the first thing that kind of caught my eye was this 1 over sine. So look for somewhere on your little slip of paper where you see a 1 over sine. Yeah, right at the top under reciprocal identity. So why don't we replace that green box with a cosecant theta? All right, this is going to sound crazy, but we're going to use factoring. Do you remember common monomial factoring? Where you factor out a common number from both terms?
Yeah.
We're going to use common monomial factoring here. Monomial just happens to be cosecant. So I'm going to take this cosecant, pull it out front, take this cosecant, pull it out front, and then put in parentheses what will be left. So see if you can see this with me. If I pull this cosecant out front of the first term, who's left? cotangent squared. And if I pull cosecant away from this term and put him up front, what's left? Pretty good. And then this should be something you can find on your paper. Ooh. Do you see it? It's in a different order, but addition can be reversed. It's under the Pythagorean identity, and it's one on the far right. And the Pythagorean identity on the far right says 1 plus cotangent squared theta equals cosecant squared theta. So my paper replacement can be cosecant squared theta. And if I have 1 here and I have 2 more here and I am multiplying, cubed. That's your end. All right, last one. Good news. It's a little bit simpler with the whole replacing and substituting. There's no weird factoring that has to occur on this one. Just a bunch of replacements. So I've been leading the way. Maybe you guys lead the way. Who has an idea of something we could replace?
So on my key concept for my notebook, I can't find any x's.
Well, they're all thetas, but theta and x is the same thing. It's just a variable that stands for an angle. Well, since nobody's come up with ideas, how about I'll give you an idea. Let's try replacing, we're on video. Let's try replacing the cotangent x. Do you see cotangent x anywhere on your paper? I see it twice. So do we want to replace it with a 1 over tan or with the cosine over sine? Absolutely. You know why? Our goal is simplifying. Keep in mind your goal. Your goal's canceling people. And we just could cancel somebody. But we still have this blue box to deal with. We can't forget that we still have a secant. So let's replace the secant with somebody.
1 over cosine of...
So my blue replacement is replacing secant with 1 over cosine. And guess what?
It's 1.
Cancel, cancel. So they're really nice when the whole entire thing cancels. Doesn't always happen. Okay? Hey everyone, thanks for watching my video. It was rough today because it was a Friday and this stuff is kind of difficult. We are going to have a pre-roll for the homework assignment because it's Friday. So I'll put it up so people in the video can see it, and then we'll be rolling in each class. Happy weekend!